This is the model of our three-way control valve in our system that directs the water to either our hot or cold water storage tanks. And the way we decided to model this is by having a supply bucket of water that will fill with either hot or cold, which goes through a hose into a flow meter into our pump, which then brings the water all the way through to a thermo well with an RTD inside of it to measure the temperature, which then moves through to our three-way control valve, and based on the temperature, it'll either open or keep this valve closed to direct water to either our hot water storage tank or our cold water storage tank.
So as our project is 75% complete, the wiring is a little messy, but I will run through the major parts of our system and how it will work. So we do have a wall outlet here, and this is going to go into our system through these terminal blocks. And this will direct our AC power to our system, and our system will distribute it as DC to run our flow meter, our pump, our RTD, and our control valve. So as a major components list, we have an SDR. This will convert our AC power to DC to power our certain components. This is our PLC, a programmable logic controller that will control the logic turning on and off the pump through a solid state relay, or it will turn on and off our control valve through a different relay here. So as we follow the power, we're going to come into our transformer, which then goes into our relay, and this relay is going to turn on and off our control valve depending on the temperature of the water. Next, we have our solid state relay, and this relay connects to our pump, which our pump will turn on and off depending if we're reading flow from our flow meter, and our PLC will be controlling all of this. Next, we have our RTD. Our RTD is just a sensor that will read the temperature from the water coming through the system, and it will tell our PLC what is happening, and then our PLC will determine whether to turn on or off our control valve. Next, we do have this temperature sensor input reader, and that just allows the PLC to read the temperature from the RTD. And that is a basic overview of our system.
There it is.
Oh, so it's coming out your side, right?
Yeah, it's on this side. Hey!
And now it's coming out my side, right?
It's going both sides.
It's going both sides. It has it flipped all the way.
Okay.
Now it's my side. Now it's...
Is it just my side?
No, it's both.
And it's still both.
Wait, so
Okay, as far as what we need to do to finish our project and where we're at, we're about 65% of the final report done, which is, we're kind of jumping ahead on that report, but that's because one of our main deliverables to Setty, or our only deliverable to Setty, is that 25-page document, which we're combining that with our final report, and Cole will go over that document and show the progress that we have on that. We're kind of combining those two documents so that we can have all of our information in one point. And we also need to work on our wire connectors. We have two different options, but we need to get a third one that is a shrink wrap option that will kind of solder the wires all together. We also need to do a little bit of voltage testing for the wire connections before we actually plug everything in. Otherwise, we need, or along with that is some safety testing, because otherwise if we plug it in prematurely, then it's going to blow our whole system, and that is going to ruin the project. So that's kind of where we're at on that. As far as what we've learned for this project so far, we've done a lot of work with coding, with elements, or with the individual parts, like choosing which parts, how to know which parts, sizing, wiring, all of these different aspects that we haven't known how to do before. We've all learned a lot about that, as well as working on better communications with our sponsor and with some of the other faculty.
So I'm just going to take this opportunity to kind of go over where our final report is at. The reason why we're including this in the video is because the final report is actually our only deliverable for our client, the Setty Family Foundation, and it also is a huge aspect of our capstone design. And so this really feels like a big part of our project, and so we just wanted to kind of demonstrate how far we've gotten on that. So obviously we have our cover page here. And our table of contents. Obviously these page numbers are going to be updated based off updates to our report, but just kind of this is every section that's going to be in our report at this point, both based off of the requirements for Setty and for capstone. We have our team information page right here. which is complete and ready to go. Our problem description we feel is complete. This was part of a lot of our assignments last semester, so we've copied pasted it, edited a few things as we kind of had greater understanding, some client and advising from professors and others locations, and small updates here and there, but really this section is done, kind of defining what we're supposed to do for both capstone and for Setty. We have our constraints and deliverables. We have our tables that are required for capstone with our deliverables, and then some of the constraints of our actual design and system. So those are pretty complete. We may add one or two as we just finish out testing and we feel, okay, this is a reasonable constraint we can add to kind of narrow things down. But that feels really complete, and we've kind of explained a little bit about the difference between the Setty Family Foundation and our capstone course and what the additional constraints there are. So we've kind of broken things down to just make it really easy to follow. And so we feel really good about the constraints and deliverables section of our report. The next section is the solutions considered. This is required specifically by Setty to kind of say, hey, what other things did you consider besides the solution that you chose? Capstone more focuses on what was the final thing you chose, but we still feel like it's valuable to have both. So that's really awesome. We have our 3 or 4 major ideas in here, and obviously including the one that we chose. We feel this is really complete. We really took our preliminary design review PowerPoint and kind of condensed it into this section of our document. So we feel this is pretty complete. We may add a sentence or two just to the lower part of this, which is our chosen design, just because as we obviously figure some last couple things out, we might want to update a little bit of this section, but overall pretty much complete. Our system overview is a more complete breakdown of the chosen design. We have a very, I think, detailed description of a high-level top-down approach for our design, as well as a schematic of said design, due to just the type of project we have with the scalability into different residential homes. The schematic is more applicable than a specifically sized design, and we talk about that in our system overview. Obviously we have our subsystems as well. A lot of these sections as well, you might notice, have these design or section requirements up at the top. We've decided to leave those in there until we're done, just because later in our project we have a portion of time where we go through our document and make sure it has everything needed. So we've just kind of left it there. So obviously that needs to be updated, but other than that, the system overview section we feel is pretty good, and the subsystem overview is also good. We have multiple paragraphs talking about each individual component of our design, and especially the ones that are vital to the performance of our design. We have not run our document through any AI at this point, but we do plan to do so, to say, hey, what sort of technical recommendations do you have? Do you feel like you could understand this as a reader? What sort of things we need to talk about a little bit more? But overall, we feel like these sections are pretty complete. Our performance review has not been done at this point, just because we're not fully done with our testing of our design, just because we want to make sure that we're safe with that electrical stuff. We don't blow the transformer, because as you'll see a little bit later, we are out of our budget, and so we want to be really careful that in our testing that we're not permanently damaging any equipment at this point. So we have not done our performance review at this point, so that's something we still need to do on this document. Our budget is right here, to speak of the devil. It is complete. We have all of the things that we've ordered for our design, our programmable logic controller, the pulse flow meters, 5-gallon buckets, all the way down. We have our total costs, we have shipping, everything. There may be a small update if we have to buy something at the store, which comes out of our own pockets at this point because we are out of budget, but our budget is complete on this document. Our project timeline, we've actually been updating as we go. We obviously have our original project timeline that was contained in our CDR right here in picture 1. We're going to add a couple paragraphs kind of about it at the end once we kind of have a complete idea. But right now we have our original project timeline and then our modified project timeline based off what's currently happened and how that's pushed our projections in the future. Kind of right here, you can see that kind of condenses and pushes out further than where it was before. But yeah, that's kind of where we're at there. We feel pretty good about this. We've kept up with that Gantt chart just as a team, part of our weekly team meetings, so we feel pretty good about that. Our design considerations, these are things that we are going to do kind of as we analyze the scalability of our project after we finished our initial testing. Just because these design considerations we've kind of interpreted to be more of higher level things where the public health, safety, welfare, global, cultural, social, environmental, really that kind of comes in after we figure out the scalability of it and how to, I guess, pitch this design to a investment firm that could mass produce it to actually install it in homes with ground source heat pumps. So a lot of these things we have not considered yet because we're still in the testing stages. Lesson learned, this is another section that we've been editing as we go, where each of us have a kind of a section where we talk about the things that we learn, and then at the end of it we're going to kind of condense all this stuff and kind of say, hey, you know, we learned this as a team, but this is kind of an individual place where we get to take notes. So we feel really good about this section as well. Recommended future work, again, we haven't started because we're not fully done with testing at this point, so nothing really to say there. Our references, we're still hunting down a couple references. We've lost a few along the way, I will say that, so we're trying to track those down, but we're adding those as we go. We've used a lot of the same references throughout it. I know I have a couple code books that I'm still working on getting the formatting for references to put them in here, but references is kind of 50% done or so. Our appendices are pretty solid at this point. They're just not organized in some of our areas. So to demonstrate, a lot of our calculations we've kind of broken into different directions. We have our calculations general, results, and our calculations energy savings and calculations cost analysis. Now we look at this cost analysis and energy savings and you're like, oh, those are blank, but really a lot of those calculations are part of our results portion and our general calculations. And so a lot of these, we have a lot of them done, we just need to organize them a little bit into each of the calculations, and that was actually part of our 2-week plan, so that's going to be taken care of very soon. So that's pretty far along, however just not organized at this point. However, our drawing package is complete. We spent a lot of time on this. We tried to make it look like an official construction drawing type thing. I work for a firm, and so we followed that convention. So we have our symbol convention here, and then we have all of our system diagrams, both our large scale schematics, highlighted aspects of our system, our other schematic here, just so you can see it from a top down, or 3D, and then our electrical plans, and then the schematic of what we're testing as a capstone physical system. And so we really feel good about our project. The one thing I will like to highlight is we're at page 33 right now, and that's obviously only going to grow as we continue to fill this in. And the Setty Family Foundation requirements, if we look at them, let me scroll up, say that the deliverable has to be a 25-page or less technical document. So we're already 8 pages over. However, some of the sections in this document are specifically for the capstone project, not for Setty. They don't want some of the stuff that we're including for capstone. And so what we're going to be doing is, once this document is complete and we have all of the requirements in there, we're actually going to be duplicating this report and then condensing each report to what each client wants for it. And so that is something that we can't start until we are complete with this report.